Okay, these notes are double replacement reactions. Now, in order for a double replacement reaction to occur, one of the products must precipitate out of solution. When we were doing the net ionic equations, that's kind of what we were doing. We were looking at the equations. I already had the states written for you, and they all occurred. So you just had to find the product, the one product, and write the ions for it. Well, now you're going to be able to look at a double replacement reaction and then tell whether that reaction will actually occur or not. Now, the precipitate will either be a solid, which is an S, liquid, or a gas. Okay, in order to tell whether a double replacement reaction will occur, we use solubility rules or a solubility table. Now, you have a solubility table in your reference guide, but tomorrow, or actually today in class, I should have given you a solubility table. If you did not get one, because I had to make up a new one last night, but if you did not get one, go ahead and get online, because I will have uploaded it onto my website so you can look at it there too, and then just get it from me the next day on Friday. So, but make sure, hopefully you have the solubility table, because you're going to need it to follow along here. If not, if you forgot it and you can't get online, then go ahead and use your old one. It's a little confusing, which is why I remade the new one. Okay, now there's going to be 4 examples here. And for each example, tell whether the following double replacement reactions will occur. If yes, you're going to rewrite using the states. So we're going to use the solubility table to tell whether the products, now the reactants are already aqueous. They're already in solution. That's how you react them. In fact, they have to be in solution or you can't do a double replacement reaction. So we're not worried about the left-hand side. Either of the 2 compounds on the left-hand side we're going to ignore. We're just going to look at the 2 compounds on the right-hand side of the arrow. One of them must be a precipitate. In other words, when you look at the solubility table, one of them has to be solid, liquid, or gas. It cannot be aqueous. So if we look on our solubility table, we're going to look for silver chloride, because Ag is silver and Cl is chloride. So we're going to find silver chloride, and you find that silver chloride is a solid. Okay, and then when you look up here, aluminum nitrate's aqueous. So we're going to rewrite this reaction using the states. Now we know, as I said, both of the reactants are automatically aqueous. Otherwise, you can't do this reaction anyway. And then 3AgCl with an S. And then I will give you a little hint. If you look on the solubility table, all nitrates, anything with an NO3 in it, is always soluble. So you don't even have to look at your solubility table. If you see NO3 in a compound, it's automatically soluble. All nitrates are soluble. Okay, so let's go to the next slide. Okay, so this time we're taking sodium hydroxide and hydrochloric acid, or hydrogen chloride, and we're getting sodium chloride. And now I'm going to rewrite this H2O. Remember, I keep telling you to rewrite H2Os as HOH, because we're going to need that to find the name of it, because it goes by hydroxide. So we're going to look for hydrogen hydroxide. So the first one, we look up sodium chloride, and we find that that's aqueous. But then when we look up hydrogen hydroxide, we find out that that's an L, a liquid. So that means this reaction does occur. Put a little check mark next to it. And then we're going to rewrite it using states. So we're going to do NaOH, which is automatically aqueous. HCl, automatically aqueous, gives us NaCl, which is aqueous. And then we can rewrite it back as water again. It's just you want to use the HOH to look it up, because it's hydrogen hydroxide. Okay, so that's that one. Now let's go to the next one. Okay, now we look up the next one. As I said, we're going to ignore the left 2 things and go to the right. So we're going to look up aluminum bromide. Now that is aqueous. And then we look up magnesium sulfate, and we find that that is also aqueous. That means this reaction does not occur. We don't have to go ahead and worry about rewriting it doing states. We could, if you want to, but which will show that it's not, the reaction doesn't occur at all. So let's go ahead and I'll rewrite it. You don't have to if you don't want to, but it might just show you that, there we go, it doesn't work because all of the products, the reactants, everything. Basically what happened is you put 2 clear liquids in there and nothing happened. You get 2 clear liquids. Actually, it looks like 1 clear liquid in the end. All of these ions are still just floating around in solution. None of them are coming together and coming out of solution. They're just kind of sitting there going, hey, how you doing? I'm not doing anything. I don't feel like reacting. So no reaction actually occurs. Okay, last one. So let's look up lead hydroxide. Now when we find lead hydroxide, we find that it is a solid. And then of course sodium nitrate, I already told you anything with NO3 is automatically aqueous. But this one does work. So we're going to go ahead and rewrite it using the states. So it's PbNO3 2 aqueous plus 2NaOH aqueous yields PbOH 2 solid plus 2NaNO3 aqueous. Now, you're also going to get a new, you got a new 6.8, 6.9, and 6.10. Hopefully you still have it. If you need another copy of that, let me know, because your classwork tomorrow is going to be 610. But of course we'll do some warm-ups in the beginning. Okay, hopefully this is pretty easy. I think this is probably one of the easiest parts of this whole unit. So hopefully you guys got it. If not, well, hopefully you'll get it in the warm-up. So I guess I will see you tomorrow. Bye.